Welcome back. This is the last part in today's exercise. In this part, I'm going to show you how to perform cloud mask in different Landsat product. So here I'm going to use two image collection type. One is the raw scene from Landsat 8 and another one is surface reflectance from Landsat 8. So this is not 1.8 but is L8 if you want to type it on your computer, but you will have access to this script as well. You can simply follow along when you wanted to follow only one thing at a time. So anything you don't want it to check, just always comment them before you run it. So what is this image collection? Simply let's understand the Landsat 8 surface reflectance. Here I'm already typing this, and this is the product that I am using. And look at the band information, and if you scroll down, there is a bit mask for aerosol, surface reflectance aerosol, for pixel quality information calculated from the CF mask algorithm. Pixel QA is 3, bit 3 is cloud shadow, and bit 5 is cloud. For the cloud masking, we need those two information. Remember that. And there are other information. For now, we don't need them. Close it and take a look at the Landsat 8. Landsat 8 raw scene. Real-time data. Landsat. Okay, I think I'm using this product. T1. So YLI T1. Let me see. Only T1. So I can type Landsat T1. Tier 1 YLI. Okay, this is the product I am using. So let's go to the band and look at the pixel bit mask for QA 0, 1, 2 to 3, 5, bit 4, 1 cloud, bit 5, 6, 1 through 3 cloud confidence, bit 7, 8 cloud shadow confidence, and then some other information. This is to show you that the cloud information in Landsat product within the same line Landsat 8 is different. The USGS produce 3 tier of data, Landsat data. Tier 1 is finely tuned with geometric and radiometric requirement fulfillment, and Tier 2 data doesn't meet the geometric or radiometric quality measurements, and real-time data that has not been evaluated 8. So to understand those Landsat product, you can go to this link. First, for the surface reflectance, let's look at the equation. How can we mask out the pixel values? As we saw earlier, the bit 3 and bit 5 both are cloud information. So one is cloud shadow, the 3 is cloud shadow, and then 5 is cloud. So we define, first create the variable saying that within that product, these 3 and 5 are something that we wanted to use here. For what? To select the pixel QA band. So these band that we select here as a QA, both of them, where if the bit has a value of 3 and value 5 should equals to 0, because we don't want it to use them. And we define that as a mask and apply that mask and return that image after masking, and we use the function. So here we have not used any depth filter or any other reducer, but we first use the cloud masking algorithm as a function here. So finally we create the composite variable where we wanted to use the median of that image product. So that's the median is one reducer. Within the collection, we always need a function. Remember, we used previously the map function before. So once we have the product, we can visualize them. And I have defined the visualization parameter. Here. So for the method number 2, which is for the raw data, as we saw earlier, we can use a simple composite algorithm to sort the pixel based on the cloudiness. So here we use the algorithm that we already have for the raw scenes, and then we want all the data in the float and display them. So we don't need to do anything as long as we use this function for the raw data set. It's pretty easy, and then simply we can run it and display them. So we'll simple composite and then composite for surface reflectance and then raw. We run it. We have not set the zoom extent at this time or zoom level, so let's zoom it by hand. Scroll down to area. Probably it will take some time to load all those data. It looks like there is nothing at the beginning, but you will see. So what we are displaying here is within the image collection from Landsat 8 when it came into operation. From there, 2013 to up until now, with all the images, there should not be any shadow, and to get the pixel value replaced for that, we use the median function. That means with all those pixels, whatever number of layers that collection has, it returns the median value. Okay, this is the basic example of cloud masking for Landsat image, and cloud masking for Sentinel image will be different. Next week we are now ready to do the image classification. So far we know how to import our SEF file is our region of interest, and we know how to reduce the image using different reducers. We also know how to reduce our feature if we need to use those feature collection from Google Earth Engine. We use example of tiger data. We also learn how to do the cloud masking. So by the end of this weekend, you should be able to understand all those and be ready to apply classification algorithm. So I'll see you next time.